Good day and Assalamualaikum. I am Jalaxi Haji Faisal. So I am here to discuss and explain the lesson 3, which is the integration of some trigonometric integrals. So we will consider in this section some conditions of which integration of the trigonometric integrals of the following forms can be done. So form number 1, sin to the power of m cosine to the power of n u du. So to evaluate an integral of this form, we will consider these two cases. So case number 1, either m or n is a positive odd integers. So if m is odd number, factor out sin u du and change the remaining sin function of even powers to cosine using the identity sin squared u plus cosine squared u equals to 1. So, number 2, if n is odd, factor out cosine u du and change the cosine function of even powers to sine using identity 1. Case 2, lower the degree powers of sine and cosine using the half angle formulas. Sin to the power of 2u equals to 1 minus cosine 2u to the power over 2. Cos to the power of 2u equals to 1 cosine squared u over 2. So here is the some example for this form. Find cosine 3x dx. So find cosine 3 to the power of 3x dx. So first copy cosine 3, cosine to the power of 3, and cosine to the power of 3x equals to cosine to the power of 2x times cosine x. Then it is equals to 1 minus sin squared x and times cosine x.
Tulod. Sige, tuloy niya rin tulod.
We can then evaluate the integral by substituting u equals to sin x, then d is equals to cosine x. So now we can solve this problem. So cosine 3 cosine x dx is equals to 2x times 1 minus u squared. So sin x minus 1 over 3 sin to the power of 3x plus c. So ito na po yung final answers. Form 2, tangent to the power of m u sec to the power of n u du. To evaluate an integral of this type, we distinguish two cases. To case number 1, n is a positive, n is an even positive integers. If n is an even, factor out sec 2 u du and change the second function of even powers to tangent using the identity tan to the power of 2u and secant to the power of 2u plus 1, and proceed by letting z equals to tan u dz equals to secant 2u du. So case number 2, m is an odd positive integers. If m is an odd, factor out tan u secant u and change the tangent function of even powers to secant using the identity. Substitute the g equals to secant u dz and secant u tan u du. So for the example, I will give you an example after the form 3. So form 3, cotangent to the power of m u cac and to the power of n u du. So to evaluate this type of integral, we consider two cases. To case number 1, n is an even positive integers. If n is an even even, factor out CAC squared u du and change the remaining the cosecant function of even powers to cotangent using the identity cotangent squared u equals to CST squared u minus 1. And proceed by letting 2 cotangent u dz equals to negative CAC squared u du. So case number 2. M is an odd positive integers. If M is an odd, factor out cotangent u, CAC u, and change the remaining the cotangent function of even powers to cosecant using the identity 5. And substitute that z equals to CAC u, dz equals to negative CAC u cotangent u du. So example number 2. Evaluate tan to the power of 6x secant to the power of 4x dx. So to evaluate this problem, first let us copy this problem. So tan 6x secant to the power of 4x dx equals to tan to the power of 6x secant. So i-divide natin yung secant 4, so magiging secant to the power of 2x and secant to the power of 2x dx, and equals to tan to the power of 6x, then 1 minus tan to the power of 2x secant 2x dx equals to u 6 1 plus u squared dx equals to u 6 plus u 8 dx equals to u 7 over 7 plus u 9 over 9 dx equals to 1 over 7 tan 7 to the power of 7x 1 9 tan to the power of 9x plus c. So, ito na po yung final answers.